So in this video we're going to discuss the general procedure you would use to determine the center of volume, center of gravity, or center of mass for each component and shape for a composite shape or a composite body. So for the first step is you're going to break your composite body or shape into parts. So let's say you had a composite shape that was composed of a square, a triangle, and a circle. Alright, this is fairly obvious the way that I've drawn it initially, but let's say you were given this as your composite shape. Alright, so your first step is you would want to break this composite shape into three components. So you would break this composite shape down into, and I'm going to highlight the filled sections here. The circle in the middle is supposed to represent a hole. Alright, so we could think of this as being three shapes. We have shape 1, which is our rectangle. Alright. Shape 2, which is our triangle. And then shape 3, which is our circle. Alright. Alright, so once we divide it in into the three shapes, what we are going to do is that, or the one thing that we already did, is that sometimes in your composite body there might be a region or a hole where there's no material at all. So for example, we have part number 3 here. Is that example. So we can think of our composite shape or a total shape on the top could be thought of as the sum of shape 1 and 2 minus shape 3. Okay, so when we calculate our moments and things, we're going to think of area 3 as being a negative area or having negative mass or weight or volume. All right, or area. So once we have that, what we want to do is we want to determine for each of the areas that we are, or volumes or lines, we want to determine what is our x tilde, y tilde, and z tilde. All right. So for a square, it's pretty simple. All right. X tilde and y tilde would be equal to length over 2. For x tilde, and then y tilde would be equal to h over 2. Now, the one thing I will mention here is that these have to be written in the global coordinate system. So it has to be, if this is our origin point, if point A is 0, 0, our x tilde and y tilde would be that. However, if A was not 0, 0 and it was 1, 2, we would have our x tilde and y tilde in that situation would be equal to 1 plus L over 2, and then it would be equal to 2 plus H over 2. Alright? So you must keep everything in mind relative to the global coordinate system. Alright? So once you have your moment arms, and once you break up your system and once you have your moment arms, the last thing to do is to sum up all your terms. Alright, so you will apply the equations we introduced in the last video or the last page of your handout, and you'll apply the center of gravity, center of mass, or centroid equations to determine the global centroid or center of volume or center of mass. So a couple of things here is that sometimes you don't have to do that many calculations because you know that something is symmetrical about an axis. So for example, in this shape here that we drew on the top of our screen, we know that the y centroid, since it's symmetric about that line, our y bar would be somewhere along that line. So y bar would be known, but x bar would be unknown. So we don't really know where x bar would be. And then I would recommend that you would do, when you do this, your calculations, to make it easy to review, is use a table to calculate it. And then if you're doing this at home, or like do your homework, I would definitely recommend that you use Microsoft Excel to check your work. All right. All right, it makes it really easy to subtract and add a lot of different composite shapes. All right. So in order to make your life easier, there's a list of common centroids of common shapes and volumes. So that way, for different, so we have areas for the most part. We have these two are lines. But the rest of this table is just a bunch of areas, and they give you some information about where the heck the centroids would be for given shapes. And then the next page does the same thing, but instead of 2D shapes, it gives you the same thing for 3D solids. Okay, so it gives you the location of it gives you the center of gravity, but if the density of the material is constant throughout, the center of gravity is going to be the same place where the center of volume would be. So it gives you for a bunch of different shapes. It gives you formulas to solve for where the center of gravity would be relative to the shape's position. All right, and that concludes this video on what analysis procedure you use to determine the centroids.